Hey guys, it's Gupta here, and so I'm here to present my final project for big data analytics, and my project is Spark Streaming. So, what Spark Streaming is basically a stream processing extension of the core Spark API, and so this is a framework that provides a really useful infrastructure where you can process live data streams in a way that it is highly scalable. You can scale to hundreds of nodes. It has very high throughput because it uses in-memory caching, and it's highly fault tolerant because it's based on a concept of resilient database bases where the sequence of operations that created it are always preserved. So you can whenever a database that data set fails, you can always recreate it quickly. And so the best thing is about the streaming one is also it allows easy integration with real-time data sources, and so, it connects like basic sources like file systems, socket connections, and aka actors. At the same time, it has good connectivity with advanced data sources like Kafka, Flume, Kinesis, and Twitter. And it's also very easy to create custom receivers of your own. And to explain Spark streaming, basically a layer on top of Spark where data streams can be transformed and batched in a sequence of RDBs. So I feel like before explaining Spark streaming, it's important to understand what is Spark and what does it do. So Spark is an open source low latency cluster computing system, and people have so they have made Spark in such a way that it holds intermediate results in memory rather than writing to the disk. And because of that, it is really performant for iterative calculations. Like today, we have Hadoop MapReduce jobs, and if we have 10 MapReduce jobs, every time they have to read from hard disk. But if you have them in memory, they're highly performant and they can run programs. Spark can run programs up to 100 times faster than Hadoop. And all of this has been is responsible of this memory abstraction called RDDs. And what these are basically immutable collection of objects which can be stored in memory or disk. And so since these are immutable, you can have parallel functional transformations. So you can only have transformations, you can't make updates. And the best thing about it is their fault tolerance, because now they have logs which just store all the transformations. So whenever you lose something in the middle, you can always just go back to your initial data set, which is consistent, and apply all these transformations to get this to the state where there was a failure. And now so the key concept for Spark streaming is basically D streams. And D streams is nothing, it's just a sequence of smaller RDDs. It's like it's a streaming computation is a series of very small deterministic batch jobs. It's like you can have it's like chopping up the live streaming to batches of X seconds, and these can be as low as half a second batches and with a latency of 1 second. And so what we're trying to see, if you look at the image, it's like input data stream is going to Spark streaming, and Spark streaming is doing nothing but just creating these small batches which still use the Spark engine to do all the processing. And now, so on this D streams, you can have multiple transformations. You can have standard RDD operations like map, reduce, join. You can have some more advanced operations like window operations. You can count in a window. Can have sophisticated join operations where you can join two streams, or you can even join streams with an RDDs, because D streams are nothing but just RDDs or sequence of RDDs. You can even have machine learning algorithms on them because it's still using the Spark engine and they are RDDs. And so Spark streaming can also output to multiple output systems like file systems, databases, dashboards as well. And so to come to my project that I'm working on working on live Twitter data stream and trying to identify trends and patterns across demographics. It's like a lot of people have done top hashtag kind of analysis, but I'm going more deeper than that to see top hashtags by different other dimensions. And also important thing is, like, right now there is a lot of spam going on Twitter. So my project is also about like filtering through all these spam messages to get relevant trending information. And so at a high level, I subscribe to real-time Twitter feed. I need to transform the Twitter stream to extract the relevant fields from the huge tweet block, which I'll show you in the next couple of slides. I process the primitive fields to provide more value. I detect possible spam messages. And then once I have this Spark streaming job, then I send the data to Elasticsearch, where it can make it where it indexes it to make it them searchable, and then I can create analytical interactive dashboards to reveal trends. So now this is the code workflow that I have. So first I connect to the Twitter streaming API using OAuth credentials. Then I create a streaming context, basically dstreams with a batch interval of 10 seconds. Then I extract important fields from the tweet blob and produce a JSON with the extracted fields and some more processed fields. Then I pass each tweet through a spam detector function and flag spam messages. Then I convert this JSON back to a map and send it to Elasticsearch cluster with the relevant mappings. And finally, on the Elasticsearch cluster, I can visualize all that data using Kibana. And so this is what a sample tweet blob looks like. It's like a JSON with a lot of fields. It says created, when was the status created, what's the ID, what was the text. It also has information about the user itself. So you can see user ID. It's a nested JSON for user, where name, screen name, user description, what was the status, and it also has stats about the user, like followers count. It also has like status count, friends count. So all this stuff is there, but it's this huge blob and you really can't make a lot of sense right now. So now my implementation, I've created two EC2 instances with Amazon Linux AMI, and one instance is used to run Spark streaming job, whereas the other one is used to run Elasticsearch and Kibana. And I have also modified the security groups to allow internal traffic as well. Then I install Elasticsearch 1.5.2 and Kibana 4.0.2 on the same instance. And so also to get Twitter streaming API, I had to create a new application and generate OAuth keys on Twitter website. And then since my project is written in Scala, I also need to install SBT build tool for Scala. And once I have SBT, I just need to define these dependencies in my build.sbd file, and that takes care of everything else. So now I'll walk you through my code. So this is the first part of my code where I kind of extract credentials from the config file, and I set Twitter4j properties. So you can see I parse using config factory. I parse the configuration file, get all the credentials. Each credential have 4 keys, and I set them for my Twitter4j API, which allows me to get Twitter streaming data. And then so now the Spark, it's like Spark streaming actually begins. It's like I create a Spark configuration and streaming context, and you can see it's a streaming context with a batch interval of 10 seconds. At the same point, I also define my Elasticsearch resources, like what's the index, Spark sender, and the index type, and where is it located, the address for it. And if you are running it on the same device, then you can just run it as localhost as well. Now, so this is the second part of my code, where once I get that tweet blob, I have to extract important fields. And so basically with all these tweets, they come with an object called status, and that object has all these properties. So that's what I do. So using stream.map, I perform this function for each tweet. I go into and I create this JSON field where I extract the user ID from status, user description, user screen name, friends count, followers count, and something like followers ratio. This is not a primitive, but this is something that I calculated, and you'll see, I'll explain in future why this is important. What I'm trying to calculate here is how many people are following you divided by how many people you follow. And this is really important for bots, spam bots, because they follow a lot of people, but they are not being followed by a lot. And then I also get a lot of geo information, language information, location, and some stats on the user, where you user status count, when was he created, what's the tweet about, and what are the hashtags. I kind of do a processing on the text to get hashtags as well. And then there's some more information on the place name and country. Now, once I have this JSON, I have to go through this function which detects all the spams. And this, so I have this idea of spam from a API called Data Sift, which develops APIs for Twitter. And so what I'm trying to do is flag recently created user, that's like any user less than a day, flag users that created little content because they're less useful, flag users with few followers. These are again to remove the bots, spam bots. Flag users with short descriptions. Flag messages with large number of hashtags because again they are like not useful as compared to statuses where less hashtags. And then messages with short content length, and short content I mean is like less than 20 characters. And then also like a lot of times you have these tweets with promotion where you have retweet and follow. So I'm also removing, say if the tweet has any of these combinations of follow and RT, I remove that. So this whole logic is that if the tweet passes through all of these filters, then it is said that it's not a spam. Otherwise, if it gets stuck in any of the filter, I say it's a spam. And so this is, you can see this is the implementation of that. So it's just returning a boolean, and I'm just doing a boolean multiplication by and you can see the 7 filters which I just explained are all listed here, like hashtag length, RT and follow combinations. And based on this function which returns a boolean value, I say that if that tweet map passed through everything, that means it's not a spam is false. If not, then spam is true. And then I just relay this data to Elasticsearch, and it's sending to the same resource that we just described in the top in the beginning. And now this is how I execute my project. I go to my CD screaming Twitter, that's my root, and then I just say sbt package run, and that takes care of everything, and it does the job of Spark submit. And you can see now every 10 seconds it's extracting data and sending. And this is what you see in Elasticsearch. So you can see on the top image here that I have this Spark sender index already there with 1.6 GB of data and about 2 million tweets. And I can even see exactly each of those tweets using this tool called Elasticsearch Head. And you can see now, rather than that complex blob, I can actually see it nicely that this tweet, what's the user language, user screen name, hashtag, everything is much more organized in this Elasticsearch. And now on top of Elasticsearch, I can easily create these Kibana dashboards. And now you can see, so on the left, I have what are the trends that's actually going around in Twitter, but what I am able to get in my dashboard, and my dashboard has total tweets over time, top tweets over time to see patterns, total number of tweets for the last hour actually, and is it a spam or not, how many are spam and how many are not, and then distribution of languages, top hashtags by language, and this is like top hashtags. So if you try to correlate this, you will see I have this I love Preciolis, and we want control as single. That's the only two, and otherwise these are other MTV, meow, and all that stuff which comes up. But now if I just put a filter where I say just give me all the tweets where spam is false, now you can see all the trending hashtags that you see on their website are much similar than to what I have now. So basically, finally trying to conclude, lessons learned, Spark Streaming is a pretty powerful technology, and I feel the good thing is the code is reusable for batch as well as stream. So at some point it might be just able to completely replace Adobe MapReduce jobs. Next thing, I also figured out the Scala is pretty powerful. Like even something like this, I could compile this whole project in less than 150 lines of code. And for some future, I feel like right now I would want to do like more machine learning to get spam detection, or maybe just join my data with natural language processing to get more sentiment analysis.